Hi, hello, welcome to another math lesson. Today's pretty short, we only have 6 slides. We're going to be solving problems with quadratics. Alright, here we go. So during this lesson you're going to learn how to create equations in 2 or more variables to represent quadratic relationships. We also want to graph equations on coordinate axis with labels and scales. So we want to be able to label stuff. Alright, so modeling with quadratics. So there are a lot of real life situations that we can model with our quadratic equations. So two of the main ones is finding the maximum area of a rectangle, surface, or space, and also finding the height of an object in relation to the time the object is in the air. So these are just a couple. There's lots of stuff that quadratics get used to model real life situations. These will just be a few. Let's start with one. Alright, Tanner is baking a rectangular cake and wants the dimensions of the cake to be 2 consecutive numbers, or 2 consecutive integers. Write an equation to represent the area of the cake based on the integers and graph it. So first of all, I'm going to have a cake. The big thing we have to look at is, what does consecutive integers mean? And that's one number that comes after another. So if I have x being my first number, a consecutive number would be like x plus 1 or x minus 1. They're numbers that are going to be right next to each other. So what we can do is we can say, well, I'm going to use this pair right here, x times x plus 1. And we know that area is equal to length multiplied by the width. So I know my area based on x, a of x, is equal to x times x plus 1. We're going to distribute that. I get x squared plus x. So there's my equation. We want you to try this now. Rosie is choosing an easel to make a painting for her sister's quinceañera, which is the 15th birthday party, or celebrating the 15th birthday party. Easels come in rectangular sizes where the width is 2 inches longer than the length. So the width is 2 inches longer than the length. Write an equation to represent the area of the easel based of the length and graph it. Okay. So really we're looking for something like this. I have some painting. I know that I have my length right here, but my width is 2 inches longer, so it'd be my length plus 2. So this one says, write an equation to represent the area of the easel on the length and graph it. Okay. So my area, we learned last time the area was length times width. So we can go L times L plus 2. Okay. Now the big thing is it wants us to graph it. There's a couple different ways we can do it. In the next slide, I'm going to show you how to graph it on the calculator, at least on my iPad calculator. And then if you need help with the Inspire how to graph it, come and see me and I'd be happy to show you on that. So the big thing though we want to say is, I have my x and my y coordinate, right? So there's my y. There's my x. But we need to understand what each of these are, right? So the x in this case, or my L, this is standing for length, and my y is standing for the area. So L plus 2, it's going to come up something like this. So the longer my length, the bigger the area is going to be, right? I have no restriction. I'm starting at 0 because that is where my I can't have negative length of my easel here, and so it's going to just keep going up. So The longer the length is, the bigger my area is going to be. Alright, an object is launched at 23.5 meters per second from an 18 meter tall platform. The equation for the graph's height, s at time t seconds after launch, is s of t equals negative 4.9 t squared plus 23.5 t plus 18. Well, we don't graph in t's, so what we're going to do is we're going to say f of x equals negative 4.9 x squared plus 23.5 x plus 18, and we're going to put that in the calculator. So I might have to bounce back and forth between some pages to remember these numbers, but let's graph this. Negative 4.9 x squared, negative 4.9 x squared plus 23.5x plus 18. Okay, so notice I can't see the top of my graph here, and that's what I want to see. So I'm going to change. If you double tap on your, at least on your graph, you can do that. This one I can pull it up, but on yours, if you just double tap right there, there we go, you can change that. So we're going to bring this up to 75 maybe. Alright, so I have my quadratic there. Now I'm going this, in this case you would have the menu button is like what you just hit for the inspires, and then we're analyzing the graph and we're looking for a maximum. So that's fairly simple. Then you're going to drag your line so that it comes right there. Alright, now let's look at what this is stating. Let's see if I can take a picture of this. We won't worry about that. So that 2.4 is how many seconds it's in the air? 2.4 seconds, and it reaches a maximum height of 46.2. So the question asks us, graph the equation and find the maximum height. We know that my y value is my height, which is 46.2 feet, or meters in this case, and it occurred at 2.4 seconds. So we said it was 46.2 meters. And it occurred at 2.4 seconds to hit that maximum height. Okay, if you have any questions about that, please come and see me. I'd be happy to help you out. Have a great day. Thanks for listening. Bye.